So hi, welcome back. This is Jordy, VMworld TV, and I'm here with Mike Foley, the technical marketing architect for vSphere, and we're going to talk about encryption. Mike, how are you?
Good, how are you?
I'm fine. So we saw day 2 in the keynote that there's a lot of cool stuff in 6.5 coming out, and one of the things was security. So can you run us through what's now in 6.5 and what we can look forward to?
Sure, I can do that. 6.5 is a really big release for vSphere security. Traditionally, security's always talked about network security like NSX and so forth. vSphere 6.5 introduces 4 main new updates. One is virtual machine encryption. The next one is vMotion encryption. The next one after that is secure boot for both ESX server and for virtual machines. And then finally, to wrap it all up, is this new enhanced logging, which will make forensics and security people really, really happy.
Okay, that sounds good. So can we talk more, for example, about VM encryption, VM encryption, data at rest and all that kind of stuff? Yeah.
Sure. So if you look at the way traditionally virtual machine encryption is done, it's done many different ways. So there's you do encryption at the array level, or you do encryption at the fiber channel bridge level, or you do encryption using a virtual storage array running on top of. And then finally you do encryption within each and every VM. And especially the last one is just not scalable, because now you have security snowflakes for every virtual machine. And think of, if you have both Windows and Linux, now you have multiple encryption solutions, and the keys for that encryption actually lives within the virtual machine. All of that just makes for a management nightmare. And we all know that if security is difficult to install and configure and to manage, then people will just find ways around it. So we're doing it differently. We're doing all of the encryption at the hypervisor level. So as the I/O comes out of the virtual machine, it's immediately encrypted and before it reaches the storage layer within the hypervisor. So it doesn't matter whether it's NFS, iSCSI, fiber channel, or even vSAN, we can support all of those. It also doesn't matter what the OS of the virtual machine is. It could be Windows, Linux, any version of Windows, any version of Linux, any version of BSD Unix even. Whatever we support as a virtual machine operating system, we can do the encryption, because as I said, it all happens underneath the virtual machine. Virtual machine has no idea that it's happening.
So I work at the NSBU, so at the NSX side of the house, and I mean, the question I get asked often, and I'm going to ask it to you,
sure.
How much latency or how much CPU performance, the standard performance questions?
Yeah, so the performance question comes up all the time. So we are leveraging the AES-NI instructions in the Intel and AMD CPUs. If you look at the roadmap that is going on with that, those instructions are getting closer and closer to near native speed, right? So existing systems that are available today, 700 megabits to 1 gigabit per second I/O coming out of that encryption engine per core, right? So we're leveraging that, but the encryption part is not the whole story. It's how much I/O is that virtual machine generating. I mean, once the disk is encrypted, what I/O is the VM writing to the disk? Is it doing a terabyte of data a day? Well, now you can do the math and figure out, it's going to slow down. But if you're doing, 100 kilobit writes to a database or 1 megabyte writes to a database, those are going to go near line speed. But then you also have the other variable of just how fast your storage I/O subsystem is. So one question I always bring up to customers is, okay, if 6.5 was available today, when would you install it? 99% of them, are going to say, I'm going to wait till update 1.
That's a tradition, of course, yeah.
So if they're going to wait till update 1, so you're thinking sometime next summer is when they're going to start rolling it out into production. I then ask, what's your next hardware refresh cycle? Because if it's next summer, and the next generation Intel stuff, they've already said is going to be much faster, and the next generation storage with NVMe and all that other stuff is going to be even faster, that the numbers that you look at today may not be reflective of the numbers that you'll get next year. The whole issue around performance is a today discussion, not where I'm going. So as Wayne Gretzky said, you always skate for where the puck is going, not for where it is. and performance is less of an issue. The key thing, the key driver here is manageability. And all you have to do is just apply a storage policy setting of encryption to that virtual machine, and it will be encrypted. You can do that with 2 lines of PowerShell.
Okay, so about key management, because I'll probably one of the other things that well, it doesn't worry me, but that I'm looking at is, are we going to use a central CA repository or a central CA store for that,
Nope.
or is that inside vCenter?
Nope, not at all. vCenter is a key manager client, and we're not using asymmetrical keys. We're not using public-private key pairs. We're using symmetric keys. That's what's usually done for block encryption, right? So what we're doing is we're partnering with a whole range of key manager providers. So for example, Vormetric, Thales, HighTrust, Gemalto, all of these provide key management interface protocol, or KMIP, 1.1 compliant key managers, and vCenter is just a client, and we will work with all of those, and we're testing even more going forward. Key management isn't a core competency of VMware. There are plenty of vendors for who can provide those services, and what you really want to think of as an IT guy around key management is, I need to have access to those keys. So the question that IT needs to ask security and people who are buying the key managers is, how available are those key managers? Do you have key managers in multiple sites that are replicating? Well, in vCenter, I can add the IP addresses of both and create like a key manager cluster, so that if one is down, vCenter will just try the other.
Cool. Think of the situation you're going to get a chicken and egg is when they get those key stores, and they actually start running them on VMs encrypted onto the disk. But we'll see. We'll get to that when we get there. So let's do one more. Yeah, secure boot for VMs. Tell me, what's that about?
Yeah. So if you look at the way the UEFI firmware works in all systems today, when I install Windows or Linux or whatever, the kernel, the bootable kernel is digitally signed, and that digital signature is chains to a certificate that lives in the firmware. So the UEFI firmware checks that certificate on boot and then says, okay, that kernel has not been tampered with. Well, that's great. That gets you the kernel, okay, but what about after the kernel? What if someone installed some code that shouldn't be there? The file system of ESX is comprised of a whole bunch of digitally signed packages called VIBs, or vSphere installation bundles. We never take anything out of the package, we just point the file system to the contents of the package. So now we can validate the whole file system by just checking the digital signature of each package rather than every file. So we don't have to sign every file. So what happens is when you turn Secure Boot on, the kernel is validated by the BIOS, and then the kernel kicks off a validation and checks each and every VIB against that digital certificate. When you have Secure Boot turned on, you are forbidden from installing unsigned code. So you have, at boot time, the ability to have cryptographically pure boot and no unsigned code running on your hypervisors.
So is that one of the features that our customers are actively asking for, or is that something that we're putting in there to show our customers, look, boom, we're taking it one step further?
It's both. Customers want to be assured that no one is tampering with the hypervisor, right? And you can't change if you have physical access to the box, all bets are off. Those boxes are usually behind multiple layers of security. You can put a password on the firmware so that can be managed. The difference between that and things like TPM and TXT is the remote attestation. So right now, in order to confirm that the box has booted cleanly, I have to ensure that no one's tampered the firmware. With TXT and TPM, that would be something I could do remotely. We don't have that yet, but stay tuned.
Okay, cool. Thank you very much, Mike. Thanks for your time. Great explanation.
Thanks.
Thank you very much.